Hey, this is Tyler. Welcome back to Spice Ferret. This is a little YouTube series that I'm doing where I'm walking you through some Arduino concepts and binary. Over the past few episodes, what we've been working on is binary addition, using logic gates to add bits together. And that's been going really well so far, so I figured let's take it to the next step and let's add memory into our system. Right here I've got our little Arduino project. There she blows. Okay, so check it out. You'll notice I added 2 new LEDs to our situation here. What I'm going to do is I'm going to accept these 2 red LEDs as inputs. And then I'm going to use the clock button to push these bits into a running total that we're going to keep track of on the blue LEDs. So that's what we're doing this episode. I'm going to just walk you through the code on the computer, demonstrate the board to you. Let's get on with it. Meet you over at the computer. Alright, you guys, we're at the code. The first thing that we changed was this button. The pin is actually still the same, but we've changed it from CN to CLK. And what that stands for is clock. So if we have multiple logic gates or multiple different processes that need to happen, the clock makes sure that they don't happen all at once. All processors have a clock, and they actually use a physical clock. We're just going to simulate that with a button press, and it's going to be a lot easier. Next up, in the loop, what I want to do is I want to make it to where if we push A or B, then we hold A and B high, even if I let go of the buttons. And so we read into an input buffer, and that's either going to be a high or a low whenever we read it. And then we also read the clock at this moment too. And that's either going to be a high or a low, but we'll get to that in a second. This is the code right here that dictates whether or not we have an A and B on the input. So if the input buffer goes high for A, then we just hold A high. This is called tying your input high. Essentially, we've made the push button permanent. So I push the button and the input buffer goes high, and then the code reads, oh hey, the input buffer is high, push A high. And then I let go of the button, input buffer goes back down to 0, but we're not setting A back to 0, so A remains high. Let's go ahead and start up our running total. I'm going to declare a few variables that we're going to need for the addition. And then we're going to test to see if the clock goes high. If the clock goes high, then we're going to do the addition. If the clock does not go high, then we are just going to stay where we were. So this is our first addition, and what we're doing is we are adding the values of A and B together. So by adding A and B together, we get 2 new variables. Remember, whenever we add, we get the outputs of S and C, which is sum and carry. And that's what these are right here. We have AB carry and AB sum. In this block, we add AB sum to our first LED pin, and then we update the LED pin after that. Same thing with the second bit, and then we're doing AB carry, because remember, AB carry is in the 2's position, so it has to be added to the second bit, not the first one. If we add it to the first one, we'll lose the bit. Now we have to carry out the addition to our 4's and 8's position. To update our 4's and 8's, what I'm doing is I'm summing it with 0. Here, if this carry goes high, we're introducing that carry here. So if we do have a carry, this is what takes care of that to go onto the second 2 bits. And we do this twice, one for the 4's and one for the 8's, right there. After we get out of that, we go ahead and we tie A and B back to low, so we can restart our loop, so we can add new variables to our running total. And then we change our LEDs. We actually take the variables that we had summed up, and then we write those to the pins so the actual LEDs will light up. That's the whole code. This code is actually already uploaded to the board, so what we're going to do is we are going to go down to the Arduino and we are going to test it out to see if it works. Behold the Arduino circuit. Alright, we've got it plugged in. That's only for power. That's all we're using that for. And we have our buttons A and B, and then our clock. Now this is why I originally used a yellow LED in this, is because I wanted to signify that that was different. So if we push the clock, nothing happens. It is actually doing the addition, but it's adding 0 to 0. So the answer to that is 0. But if we pass it an A, okay, now you see the LED came on, but that's actually only tied to the button. What that has done is it set the input buffer high, so also A is now high. And now it's tied high, and we're looping through our main loop, but A is still high and B is still low. If we hit the clock, see, it adds A to our output string here, and then A goes back low. So if we hit the clock again, nothing happens. It's just adding 0 to 1 now. If we hit B, we've added a 1 into the input buffer, so it's a 0 and a 1 that we're adding together, and then we're going to add it to this string of LEDs whenever we hit the clock. So what we should get is a 2 on the output, because 1 plus 1 equals 2. Boom. Alright, so that checks out. Now, let's go ahead and do A and B. So now the A and B are held high in the memory of the Arduino, and we should add 2 to that. Now, we have a 2 on the output, and we know that whenever you add 2 to 2, you get 4, which is also the same as multiplying 2 by 2. So what should happen is we should get a shift. It should shift to the right 1 bit. Boom. See how that works? Alright, so let's walk through it. That's a 5, a 6, a 7. If we push both, a 9, 10, 11, 12. Hold on. 12? There we go. 13, 14, and 15. Now, what's going to happen when I push the button now? It's going to explode. No, I'm just kidding. It rolls over to 0, because we do have a carry coming out of that last bit to roll over to the next one, but we don't have an LED there or a place in memory to hold it, so it essentially just filters away into nothing. And that's rollover. So like if you've ever been playing a video game and then you like clog up a value, you increase a value to where it's like really high, and then all of a sudden it goes negative or goes back to 0, that's what's happening there. The value of what's being stored in memory is beyond what can be stored, and so it just rolls over to either a lower value or the other extreme, which in this case is 0, because we're not doing any negatives or anything in this. We can do negatives, but that'll require a little more work. But yeah, guys, so that's it. It's working, and it's functional, so that's it. Alright, you guys, that's it. So today we went over the Arduino's memory, essentially. We held a few variables outside of the loop, so we were able to keep track of them even though we were doing processes on the board. So, so far in this video course, what we've done is in this video series, what we've done is we have taken a half adder and demonstrated how that works. We've upgraded that to a full adder, demonstrated how that works, and now what we've done is we've added memory. So this is the third installment in our Arduino series where we have now added memory to our board so that we can keep track of the bits we put into the system. And we demonstrated that by keeping a running total of our variables. So I want to thank you guys for tuning in. It was a lot of fun making this, and I hope we can do some more projects in the future. If you like this content, press the subscribe button. It's probably like right there. So also leave a like and share the video to your friends, people who you think might be interested in this really nerdy crap. So we'll see you next time. Thank you guys for tuning in.